Welcome to the companion video to the University of California Division of Agriculture Natural Resources publication number 8014, entitled Sediment Delivery Inventory and Monitoring, a Method for Water Quality Management in Rangeland Watersheds. To get the full benefit, we suggest having a blank worksheet and photographic record in front of you as you watch this video. This publication is available either by contacting your local University of California Cooperative Extension office or through the Internet at this address. This easy-to-use worksheet and photographic record method gives any landowner a way to monitor sites of erosion and sediment delivery for use in land management decisions or to demonstrate compliance with water quality regulations. From the North Coast Regional Water Quality Control Board, Rebecca Fitzgerald elaborates.
The sediment inventory worksheet that the University of California Cooperative Extension has developed is a really beneficial tool, at least that's the regional board's perspective, for landowners to inventory and then to prioritize sources of sediment that are on their property. We feel it's a really easy, straightforward, do-it-yourself worksheet that the landowner can go out on their property and follow and inventory their sites and do it in a way that won't take a lot of time and won't take a lot of effort, but will get the information that we at Water Quality would like to see to be assured that sediment sources are being addressed.
The three monitoring objectives for the worksheet and photographic record are ease of use by private landowners or managers, water quality regulation compliance, and incorporation of terminology from the Natural Resources Conservation Services, or NRCS, Field Office Technical Guide, Section 4, Conservation Practices. The NRCS is an important technical resource for the design and installation of sediment delivery control measures. Familiarity with their terms makes it easier for you to interact with NRCS. The worksheet and photographic record were developed in collaboration with agricultural landowners, Regional Water Quality Control Board staff, NRCS staff, and University of California Cooperative Extension advisors and specialists. These groups tested and revised the worksheet and record method on private lands to ensure that the three monitoring objectives were met. Through scientific application of the worksheet, important findings on causes of sediment provides guidance in using limited resources for mitigation. As a final note, it is very important to understand that the worksheet and photo record is not intended to monitor in-stream sediment. In-stream sediment monitoring is very expensive. The money for it could be better spent on installing and maintaining control measures. Therefore, the worksheet and record were created to assist you in developing a prioritized list of cost-effective erosion control projects and to monitor the success or failure of those projects. There are three main sections. They include a site identification and criteria section, a description and control measure section, and a prioritization, cost, and completion section. Selecting a sediment delivery site is the first step to inventorying and monitoring it. Site selection is based on your knowledge of the property and would include those areas with past or present erosion and those with potential to erode. It is important to account for erosion created by off-property and natural factors, as well as your land management. Since influences and quantities of sediment delivery are site-specific, screen all sites using these four criteria. Potentially deliverable sediment that is actually delivered to a water course, potential sediment delivery that is management-induced, potential sediment delivery that is reasonably responsive to mitigation, and finally, potentially deliverable sediment that is greater than an established volume threshold. Now, it's important to distinguish between potential and historical sediment delivery when selecting a site. When looking at a site where erosion has occurred, ask yourself, if I don't fix this site, will it continue to deliver sediment? Some sites stabilize on their own. This judgment call is based on your long-term knowledge about your land. Here are the 4 site selection criteria contained in the worksheet. Deliverable sediment. Soil erosion can take place without delivery of sediment to a watercourse. Select sites where sediment goes into a watercourse and where the delivery impacts the watercourse's beneficial uses. Degradation of fish habitat is one example of an impact of sediment on a beneficial use. Management-induced erosion, caused by human activities, also known as anthropogenic erosion. A good example is a poorly constructed dirt road. The opposite of this type of sediment delivery site is called a natural sediment delivery site. Sometimes massed wasting on hill slopes is used as an example. We recommend that both types of sites be inventoried and monitored. It's useful to distinguish between the 2 types of sediment delivery sites when determining which sites to control by management. Next is mitigation potential. There are many methods for controlling soil erosion and sediment delivery sites. They vary with regards to cost, time, and engineering requirements. Some sites can only be controlled through a very large and extremely costly engineering project. These types of sites are described as not reasonably responding to mitigation. Sediment delivery sites that are controllable with readily available materials and knowledge are described as reasonably responding to mitigation. These are the sites you'll want to select, prioritize, control, and monitor. Obviously, making the decision that a site reasonably responds to mitigation is a field judgment call. When in doubt, you might seek the opinion of a Regional Water Quality Control Board staff person. The 4th and final site selection criterion contained in the worksheet is volume threshold. This metric is an established amount of potentially deliverable sediment. Threshold values usually range between 10 and 50 cubic yards. Volume threshold should be based on site-specific climate, soils, and vegetative conditions, as well as relevant regulatory requirements. In reviewing the 4 selection site criteria, those that receive yes responses to all 4 criteria are called source sites. These are sites with sediment delivery which must be inventoried, prioritized, controlled, and monitored. Sites that exceed a volume threshold but do not receive yes responses to the first 3 criteria are termed unstable areas. You should inventory and monitor unstable areas with photographs. These are sites that you cannot always address and control. These types of sites could possibly be addressed through a grant program in a watershed-scale restoration project.
We realize that fixing these sources can require some time and some money. So one of the things that we are trying to do with the Regional Water Board is focus some of the grant funds that we do have access to the watersheds where there are TMDL, sediment TMDL implementation plans in effect. And we have a few different funding sources, one of which is specifically for implementation, the fix, the repair, the control of sediment sources, and that's the 319H program that comes out of the Clean Water Act, Section 319H. But we are trying to really focus our own review of requests for grant funds so that those who are in these watersheds have a better chance of getting those funds.
Now that you understand how to select a site, let's start the inventory or site characterization by revisiting the worksheet in detail. Site characterization generates the information needed for baseline monitoring, which is an inventory of sediment delivery from unstable areas and source sites. It also collects the information needed to prioritize the site for control measure implementation. We will walk through 2 examples. The first is a site that meets the criteria as an unstable area, and the second is a site that qualifies as a source site. The site number is a unique identifying number that you systematically assign to each site you inventory. Since this is our first example, we'll call this site number 1. The location description may be a legal description, a GPS waypoint, or the simple name of the adjoining pasture or road. The purpose is to help identify where the site is located, not only for you, but for anyone else with a copy of the worksheet. We'll call this location Natural Landslide in North Pasture. Let's look at the 4 site selection criteria as it relates to this site. The first question asks if the sediment is deliverable to service watercourse. In other words, is it discharging into a stream or a creek? Here the answer is yes. The water is just below the slide area. The second question asks, is it management induced? Here the answer is no, since this is a natural feature and not caused by human activity. At this point you realize the landowner is not responsible for repairing the site, since it is very large and would not be reasonably responsive to mitigation, the third criteria. For this example, we'll use a volume threshold, or VT, equal to 10 cubic yards, about a dump truck full of dirt. This site certainly has the potential to deliver more than 10 cubic yards, so you would place a Y next to the last criteria. So, in summary of this particular site selection criteria, there were not yes answers to all 4 criteria. Therefore, this site is an unstable area and not a source site. Since this is an unstable area, however, you will need to indicate on the worksheet whether it will be monitored with photo points. In this example, we'll follow our own recommendation and check that we intend to photo point monitor this unstable area. As part of the inventory of an unstable area, you'll continue by filling in the sections Category, Process, Influence, and Potential Control Measure. For Category and Process, you'll check only one item for each. For Influence and Potential Control, you'll check all the items that apply. In this example, we'll check the category is riparian, the process is mass wasting, the influence is natural, historical, and upstream sediment. Since this is an unstable area, we don't have to fix it, but we will monitor it and make sure that our current activities are not adding to the problem. Check the box next to Monitoring Only under the Potential Control Measure section. This completes the worksheet for an unstable area. Notice that we did not use the section Sediment Volume or Prioritization. Again, that's because this is an unstable area and we are not required to fix it. Now let's look at an example that will meet the criteria of a source site. Using the worksheet for this example, we will call it site number 2. The location description is culvert on road to horse pasture. Okay, let's go through the site selection criteria to see if it is a source site that we'll have to fix. Is it deliverable to surface watercourse? To find out, we have to walk the length of the gully to see if it actually connects to a watercourse. As we do this, we try to estimate the length in yards or feet by our natural stride or length between steps. We'll need this later for estimating sediment volume. The answer here is yes, it is deliverable. Is it management induced? Yes, due to the road and road drainage. Is it reasonably responsive to mitigation? Yes. Is the potential volume threshold greater than, and here we'll use the same figure of 10 cubic yards? At this point, just looking at it, we think it has, but to be sure, we'll use the next section called Sediment Volume to calculate both the eroded volume and the potential volume. We also need the information from this section for later when we prioritize this site for control. Now, when we walked the length of the gully, we paced off the length and estimated it to be 40 yards long. We also estimated the width to be 3 1/3 yards. We used a staff gauge to estimate the height to be 4 yards. A simple staff gauge is made by either using a piece of wood at least 6 feet long or a telescoping paint roller handle by marking it with 1-foot increments that can be seen from a distance. Let's enter this information onto the worksheet and multiply them together to give us the total eroded volume in cubic yards. Had we done our measurements in feet instead of yards, we could still multiply the length, width, and depth, but we would then divide the total by 27 cubic feet per cubic yard to calculate the volume in cubic yards. The estimate of the sediment volume that has been eroded is not as important as the estimate of potential sediment volume that could be delivered to a watercourse if we did not fix the problem. However, it is easier to measure and gives perspective when estimating the potential sediment volume. To estimate the potential volume, use a staff gauge or pace off the distances. Enter into the worksheet your estimates for height, width, and length in yards, then multiply together to calculate the volume in cubic yards, just as we did for the eroded volume estimate earlier. Don't be too concerned that your estimates may be too low or too high. The Regional Water Quality Control Board staff are willing to come out and discuss these estimates with you. They are only concerned if their estimates differ from yours by an order of magnitude. For example, let's say that you've calculated the potential volume of a site to be 100 cubic yards. The staff person estimates it more like 120 cubic yards. These values are so close that in most instances, you have calculated a reasonable estimate. If, on the other hand, yours and the staff's differed by, say, several hundred or even 1,000 cubic yards, then you would probably need to re-estimate your calculations. The last part of the sediment volume section is to place a check mark by your estimate of the percent of the potential sediment that will enter the watercourse. You should estimate this percentage to the nearest of these four ranges: 0 to 30%, 30 to 60%, 60 to 90%, and 90 to 100%. Soil type, slope, distance to watercourse, hydrologic connectivity, and vegetation is considered when making this estimation. To help you make an estimate, you should know that sediment delivery from stream bank cutting would be 90 to 100% deliverable, while sediment delivery from hill slope sites not in the watercourse would be lower. Likewise, a site that is well vegetated and covered with dry vegetative matter will have a lower percentage deliverable than bare soil. For our example, we'll estimate that 60 to 90% is deliverable. Now that we know the potential volume and percent deliverable, we can complete the site selection criteria for our example. Since all of our answers are yes, this location is a source site and not an unstable area. As a result, we skip the unstable area section and fill out the category, process, influence, and potential control measures sections. The category is road. The process is gully. The influences are road drainage design and culvert design. The potential control measures are road improvement and/or grade stabilization. Since source sites must be controlled, they also require that a method is used to prioritize them. Which method you use to prioritize sites is largely up to you, but the Regional Water Quality Control Board suggests you document how you came up with your list of prioritized source sites for control measures. The worksheet has a simple method for you to create a priority score based on criteria that take into account potential sediment volume and percent deliverable and balances it with assistance needed, time required, and total cost of the project. In this way, control measures requiring the least cost and time, as well as sites with the highest sediment delivery potential, receive the highest scores. Let's look at the prioritization section and use the score sheet located at the very bottom of the worksheet to select the points and complete a priority score for our source site example. For our example, you need to know that we have access to our own road grader and backhoe. We're not working in a watercourse, so we don't need a permit to do the work. We think we can do the work needed in about a week, and it should only cost us between $100 and $1,000, figuring fuel and labor costs. As a result, for assistance needed, we'll write in minimal. Looking at the score sheet, we see that this section is given 3 points. For estimated time, we'll write in 1 week. From the score sheet, this choice gets 2 points. For estimated cost, we'll write in our estimate of $100 to $1,000, and it gets 3 points. For potential volume, we calculated this under the sediment volume section, so we'll copy that value here. Looking at the score sheet, this gets 6 points. For percent deliverable, again, we estimated this under the sediment volume section as 60 to 90%, so we'll copy that value here. And from the score sheet, we see it gets 6 points. We now add up all the points for a total priority score equal to 20. The projects that receive the most points would be the ones done first when you compare them to other sites with lower priority scores. Notice that the worksheet provides 2 additional lines under the prioritization section: total project cost and date completed. This helps you have a permanent record of all the projects completed and will assist you in estimating costs for future projects. Congratulations! You now know how to use the worksheet to inventory both unstable areas and sediment source sites. Before you leave the sites and plan to implement the control projects, it is extremely important that you set up the monitoring program. Monitoring sediment delivery is best accomplished by using a method known as Photopoint Monitoring. This method works well because it captures the complete inventory or baseline of the landscape and is a relatively quick and easy process. As you take successive photographs of the same site over several years, you'll document and monitor the implementation and effectiveness of control measures. Several different cameras may be used for Photopoint monitoring and can include conventional cameras, digital cameras, and video cameras. The most important feature is the ability to record the date on the photo you take. For monitoring trends over time, you must come back to the same exact point every time you take a picture. Therefore, you'll need to permanently mark each photo point with a fence post, ground marker, or other suitable object. Markers must be made of durable material that can withstand climatic conditions over a long period of time. They must withstand livestock disturbance while not harming livestock or equipment. Handheld GPS units are good for establishing photo points too. Once you've established the markers, record their locations and the dates you take photos using the photographic record included with the publication 8014 Sediment Delivery Inventory and Monitoring, a Method for Water Quality Management in Rangeland Watersheds. Let's take a look at the photographic record in detail. It is divided into 3 sections: monitoring site location, witness and photo point map, and photograph record. The monitoring site location describes where you or anyone using the record will find the photo point marker. It includes general information about marker location on the property. A compass heading from the photo point marker is recorded and used to give the direction in which to photograph. Record any noticeable landmarks and especially a witness point if needed. Witness points are places where you could stand and be able to see and locate the photo point. If a site requires a second or third photo point, like for the reach of a stream, you can record the same information in the spaces provided. Sediment delivery sites along a stream reach use 3 photo shots: upstream, downstream, and across the channel. The witness and photo point map section provides an area for you to sketch and make notes about these locations. Again, the goal is to provide enough detailed information for you or others to find these points over several years of monitoring. You should also indicate on your ranch map or aerial photograph of your property where these photo points are located. Give a unique number to each photo point to distinguish them from each other. The photograph record provides a space to record detailed information on each photo taken, including date and time, photographer, photo point number, camera lens film speed, roll and frame number if a conventional camera was used, and other observations of details specific to that particular year or condition, such as changes in weather conditions and management practices. Effective Photopoint monitoring requires consistency in taking photos from year to year. You can maintain this consistency by following these suggestions. Either use a date-back camera or a digital one with a date feature that records at least the date on the picture. Make sure the date is correctly set. Be familiar with where the date is placed on the picture so it will show. Dark areas of the photo are usually best. When taking the photos, carefully follow the information previously recorded for each photo point, including using a similar camera, lens, film, and settings. Take the photographs during the same season every year and at the same time of day. Use a staff gauge to provide scale in the photo. Now that you understand through this video how to use both the Sediment Inventory Worksheet and the Photopoint Monitoring Record, it is important to get out and start using them on your own property. When you're done, store the completed worksheet, photograph record, and photographs with your other important landowner records. Document and file each successive year's photographs with the corresponding worksheet and record. By using this worksheet and the photographic record method, any landowner now has a way to monitor sites of erosion and sediment delivery. It makes it possible to document the effects of climate, soil conditions, and off-property factors that cause sediment delivery beyond your control, and also helps you adapt your land management decisions to comply with water quality regulations.